So here we have another example. In this question, we're asked to use the midpoint rule with n equals 5 to estimate the area under the curve f at x equals 1 over x from x equals 1 to x equals 2. So when they're telling us that n equals 5 here, obviously they're just telling us the number of intervals. If we're using the midpoint rule, what we remember is our formula here is that the area was equal to, our approximation for the area was the sum from I equals 1 to I equals whatever, in this case n, of value of our function, x equals I minus 1, plus x equals I, all divided by 2, because we're taking the midpoint of each little rectangle, or the average, to get the x value, and multiplying it by delta x. Okay. So we've got our number of intervals here. We know that n is equal to 5. We've already highlighted that. We know what our function is. Our function is 1 over x. And we also need to know what our width of each rectangle is. Our delta x is going to be. So we know that we can calculate that kind of the same way we did in the last example. We know we want to go from 1 to 2. So we can say that we want to go, the range that we want is from 1 to 2, and we want to divide that range into 5 intervals because n equals 5. So 2 minus 1 is just 1. 1 divided by 5, 0.2. So that's our value for delta x in this formula. Now, how would I set this question up? You could try subbing everything into the formula. What I might do is actually make myself a little table so I can sort of figure out a little bit better what the midpoints are. Remember, this part of our formula here represents the midpoint of each of our rectangles, and we want to evaluate the function at that midpoint value. So we know we're going to have 5 intervals. We're going to have one that starts at kind of, do this in a different color, our starting point, x0, and then we're going to have an interval from x0 to x1, from x1 to x2, x2 to x3, x3 to x4, and x4 to x5. So 1, 2, 3, 4, 5 intervals. We know the values of each of these points here. 1, 1.2, 1.4, 1.6, 1.8, and then 2.0, because we're going from 1 to 2. Once I've got that, it's pretty easy to figure out what my midpoints are. Okay, I know that my midpoint here between 1 and 1.2 is going to be 1.1. Similarly, between 1.2 and 1.4, my midpoint is going to be 1.3. So my midpoints, I can kind of figure these out. Those are my midpoints. So I don't have to do this average every time. I mean, because this is just the midpoint, I'm just going to put my value in there for my midpoint. So I can take this sum, my area expression here, okay, and I'm just going to write out what it is. My first term is going to be f at my first midpoint, so f at 1.1 times my width here, 0.2. To this, I'm going to add f at 1.3 times, again, times 0.2, plus f at 1.5 times 0.2, plus f at 1.7 times 0.2, plus f at 1.9 times 0.2, and that's my formula for the area. Now, what is my function here? My function is 1 over x. So before I work in that function, what I notice is I've got a 0.2 that is common to each one of my terms. So I can factor out that 0.2. 0.2 times, and I know my function is 1 over x, so f at x is going to be, well, f at x1 is going to be 1 over 1.1, 1 over 1.3, 1 over 1.5, 1 over 1.7, 1 over 1.9. And at this point, this is something I can just plug into my calculator and get 0.69. So that's my estimate, my midpoint estimate for doing the for the area from 1 to 2. Okay. Here's a third example where they give us a function, but they don't tell us what the function is. Instead, what they give us is the value of the function at certain x values. So the function f is continuous on the interval 1 to 9, and f is always greater than 0, so it's always positive. And they give us selected values of f shown below in the table. Using 4 midpoint rectangles, approximate the area under the curve of f from x equals 1 to x equals 9. So let's start by figuring out delta x here, or how big each one of our, width of each one of our rectangles. We want to go from 9 to 1, and we want to split this entire thing into 4 rectangles. So each rectangle has to be 8 over 4, has to have a width of 2. So we can look at our table and sort of think about how we're going to divide it into these rectangles. We're going to have one rectangle from here to here, one from here to here, one from here to here, and then one from, hold on, 1 to 2. Oh no, sorry, I've done this completely wrong. Our first rectangle is going to start at 1 and it's going to end at 3. Our next one is going to start at 3 and end at 5. Our next one is going to start at 5 and end at 7. And then our last one is going to start at 7 and end at 9. This is 1, 2, 3, 4. And this point right here would be sort of our x0. Okay. So we can sort of do the same sort of thing we did last time, is we can set up another little table here where we figure out what our midpoints are. We've got 4 intervals here. This table won't be exactly the same as the other one. So we've got 4 intervals, 1, 2, 3, and 4. What's our midpoint for each one? Well, our midpoint for interval 1 is going to be 2. Our midpoint for interval 2 is going to be, let's see, it's got to be halfway between 3 and 5. It's going to be 4. And then 6 and 8 for our next 2. So our area, if we can figure out what this, remember the area formula for midpoints is that our area approximation is the sum from 1 to n, or in this case, yeah, n, our function evaluated at our midpoint, okay, times delta x. So we can write out explicitly what this sum is going to be. Our first one is going to be, our midpoint is 2, so it's going to be f at 2 times 2, because that's the width of each one of our intervals. We're going to have f at 4 times 2 plus f at 6 times 2 plus f at 8 times 2. And then to evaluate this, we just want to read the values of f that were given up here in this table. So f at 2 is 1.41. We want to multiply that by 2. F at 4 is 2. F at 6 is 2.45 times 2. F at 8 is 2.83. And times 2. And now we just punch all this stuff into our calculator, and we should work out to 17.38. So that's our estimate for the area under the curve.